Hi everyone, it's Michael. So I know I haven't posted a problem in a while, um, and I've been solving problems, but I've kind of been thinking about what are the best problems to put on my channel. So I hope to get the ball rolling again. Um, so here is a very nice problem from a math Olympiad in Danube. So I've never heard of this Olympiad before, but it's in Europe, and it was posted by Parmenides again, so thanks as always for posting it. And I hope you all enjoy it. So if you want to try to solve it, feel free to pause the video. Alright, so now I'm going to go over the solution. So we have a cyclic quadrilateral ABCD, and the diagonals AC and BD meet at O. I is the incenter of ABC, and J is the incenter of ABD. And IJ meets OA at M and OB at N, and we want to show that triangle OMN is isosceles. Okay, so this is pretty interesting. So there was another poster on the Art of Problem Solving forum, which you can see in the link below. I feel like he probably gave a slightly simpler solution than mine, but mine has a lot of interesting ideas. So I'm going to show you mine. So one thing, so if I is the incenter of triangle ABC, I want to try to leverage that. And often if you have a cyclic quadrilateral like this, it's good to extend AI to meet the circumcircle at a point E. And then we know that E has to be the midpoint of arc BC. And that's because since AI is an angle bisector, angle BAE has to equal angle CAE. And so since equal angles intercept equal arcs, arc BE has to equal arc CE. And then I'm going to do the same. I'm going to extend BJ to meet arc AD at a point F. And then F has to be the midpoint of arc AD. So I'm going to write that out here. But before I do that, I'm going to do one more thing, and I'll explain why I'm doing this. I'm going to extend MN to meet the circumcircle at 2 points G and H. So first I'm going to write out what I said. So like I mentioned, E is the midpoint of arc BC, and F is the midpoint of arc AD. All right. Now I'm gonna kind of tell you why I created this segment GH. So basically, we want to show that triangle OMN is isosceles. So that's the same as showing that angle ONM is equal to angle OMN. Now, how do we get a handle on angle ONM? So there's a certain theorem, I brought it up before on my channel, but the angle between any two chords in a circle is always equal to half the sum of the intercepted arcs. So basically angle ONM, that's the angle between chords BD and GH, and so that has to be half of arc BG plus half of arc DH. So most of you have probably seen this before, but if you haven't, it's not too hard to prove that fact. So I'm going to write that out there. Actually, I did OMN first, but in the same way, so angle OMN, it's the angle between chords GH and AC, so it has to be half of arc GC plus arc AH. And then what I said earlier, angle ONM is half of arc BG plus half of arc DH. Okay, so we want to show that angle OMN is equal to angle ONM, because that would prove that OMN is isosceles. And usually when we want to show two things are equal, maybe we subtract them, maybe we try to set the right-hand sides equal. But what I'm going to do is I'm actually going to add these two. So I know it's kind of weird, right? I want to show two things are equal, and so I add them together. But you'll see it works. It's pretty nice. So if I add the two left sides, which I want to show are equal, I get half, and then arc BG plus arc GC is arc BC, and arc AH plus arc HD is arc AD. So that explains why this is true. And the whole reason I did this is because I want to leverage that E is the midpoint of arc BC and F is the midpoint of arc AD. So if I get half of arc BC, that lets me potentially leverage points E and F. Okay, so half of arc BC is arc BE, and half of arc AD is arc DF. And so what I'm going to do with this is I'm going to use that same theorem all over again. So first I'm going to, so what's half of arc BE plus half of arc DF? So if I draw the chord EF, then the angle between those two chords, so I'm going to label the intersection point K, but basically angle DKF has to be half of arc BE plus half of arc DF. So it's half of this expression. So angle DKF is actually, this is actually equal to twice angle DKF. Okay, so now it looks like we're getting somewhere because we want to show that these two things are equal, OMN and ONM, but we've shown that their sum is twice DKF. So basically we want to show that each one individually is equal to DKF, and that would solve the problem. So we want to show that DKF is equal to ONM, but that's the same as showing that GH is parallel to EF, because those two angles are corresponding angles, ONM and OKF. Okay, so we want to show that EF is parallel to GH, and now we can use Rimes' theorem, which I've mentioned many times on my channel. But basically, if it were true that those two are parallel, then since ABEF is cyclic, GH is a chord of the circle that's parallel to EF. So if you see where that chord of the circle cuts the two cross segments, AE and BF at points I and J, if they were indeed parallel, those two lines, then by Rimes' theorem, that would also mean that ABIJ would have to be cyclic. So we want to show that ABIJ is cyclic, and then we can work in the reverse direction. And that turns out to just be an angle chase, which I'm going to show here. So we can show that angle AIB is equal to angle AJB. Okay, so I'm going to show you the angle chase that leads to that. So I'm just going to write it out. So angle AIB is the same as BIA. So angle BIA, that's 180 minus. So if we look at triangle BIA, that's 180 minus IBA, and IBA is half of CBA, and that's because I is the incenter. And then minus angle IAB, and angle IAB is half of angle CAB, because again, I is the incenter, so it lies on all the angle bisectors. Okay, so BIA is 180 minus half CBA minus half CAB, and we can pull the half out. And then CBA plus CAB, if you look at triangle ABC, that's simply 180 minus BCA. Okay, so BIA is this expression, 180 minus half of 180 minus BCA. But we could essentially, everything we did here, we could essentially do the same thing with angle BJA. So I'm going to sort of just do that, but in the reverse direction. So you know that angle BCA is angle BDA. So this expression is equal to this. But then if we use the same logic for angle BJA that I just did, this would have to equal angle BJA. And so we have angle BIA is equal to angle BJA. And so BIJA has to be a cyclic quadrilateral, which is what we wanted to show. Okay, so now we've basically bottomed out. Now it's all uphill from here, because once we know that BIJA is cyclic, basically by the converse of Rimes' theorem, that would mean that we could show that GH is parallel to EF, as I said before. So instead of just using Rimes' theorem, I'm going to write out the proof because it's very short. But we want to show that GH is parallel to EF. and that turns out to just be a simple angle chase. So we have angle AIJ is equal to angle ABJ. That's because we just showed that BIJA is cyclic. And ABJ, that's equal to angle ABF. Maybe I could have inserted that here. But angle ABF is equal to angle AEF because ABEF is cyclic and they intercept equal arcs. So if angle AIJ is equal to angle AEF, that means IJ is parallel to EF, or in other words, GH is parallel to EF. And so now we're almost there, basically. If it's true that those two are parallel, then that would mean that ONM has to equal DKF, because they're corresponding angles. So actually, it would probably make more sense to put ONM is equal to DKF, because they're corresponding angles. But this actually, I got lucky, this happens to be true also, because if ONM is DKF, then since the sum of the two is twice DKF, each of the individual ones has to equal DKF. And so if OMN and ONM are both equal to DKF, then they have to be equal to each other, and that solves the problem, because then OMN has to be isosceles. So I hope you all enjoyed this. This was a fun little one. And like I mentioned, there is a simpler solution on the Art of Problem Solving forum, so see if you can find it. I'd bet that that is a solution that most of you will come up with actually. So if you like this video, give it a thumbs up. And if you want to see more like this, feel free to subscribe to my channel. Thanks, everyone.